So SMT, as you can see from all these observations and experiments I just mentioned, is directly, observationally, experimentally falsified. So you have to get rid of it. Like, I'm sorry, it just doesn't work. It's a wrong model. It's a wrong theory. Greetings, this is Eugene the Philosopher, the greatest living philosopher after the unfortunate passing of Quentin Robert de Nameland, who has been the greatest living philosopher before me. Let's talk about cancer. Now, you might think that, well, cancer is such a rare disease, right, that, well, maybe you're one of the unfortunates who got it, but overall, like, it's not very impactful to humanity as a whole. But you would be absolutely wrong in this respect, because cancer is actually the second leading cause of death, again, humanity-wide. The first is cardiovascular disease, in case you're interested. So it's roughly 1/3 of all deaths is cardiovascular diseases, and 1/5 of all deaths, that is the second most prevalent, is cancer. So cancer is very relevant, okay? That's for like the introduction to this video, okay? Now, what is cancer? Cancer is a disease of uncontrolled cell proliferation, or division if you wish, where transformed cells spread to the other parts of the body. Now, one of the most like paramount properties of these transformed cells, like what are we even talking about, is they lose their differentiation. So they're not doing what they should do, you know, they lose their functional weight. They don't do anything useful in the body, basically, all right? So cancers are usually categorized based on the tissue of origin, like, so you have different names of these tumor things, these tumors. For example, you have carcinoma in case of epithelial cells, like if there's a tumor in epithelium. You have sarcoma, you have leukemia, melanoma, lymphoma, and some others, etc., etc. That doesn't really matter to us much. What matters to us much here on the channel called Eugene the Philosopher is the models, right? The theories, our view of what is happening. And this is what I want to talk about, like about a prevalent theory and its failures, essentially, and about an alternative theory which hopefully will replace the prevalent theory. So the main model of carcinogenesis today is the so-called somatic mutation theory, or SMT. I may sometimes forget to decipher this, so I may sometimes just say the word SMT, which would stand for, again, somatic mutation theory. So it assumes that cancer is a genetic disease, all right, in which a sequence of mutations within a single cell leads to its basically breaking and starting to do all this malicious stuff, such as proliferation and the loss of differentiation, okay? These sort of paramount properties of cancer cells. So despite the mainstream, again, I hate this term, but let's use it as a shorthand, acknowledgement of this theory, and absolutely like gigantic resources devoted to the development of this theory. Basically, if you donate to any cancer research right now, it's going to the SMT, somatic mutation theory, kind of driven research, all right? There hasn't been much progress in cancer treatment in many decades. Like, there is some progress, of course. I mean, there will be even like a cosmetic progress anyway, right? But no fundamental shifts have taken place, again, in quite a while, actually, right? And here the situation is kind of anecdotally similar to the case of thermonuclear fusion. Watch my video about it if you wish to know more, all right, about all the failures of thermonuclear fusion as a concept and as a practical applied way of energy generation. So anyways, to sum up this brief segment, people are understandably looking at alternatives to SMT, to the somatic mutation theory, which again states fundamentally that the cancer arises from a sequence of mutations within a single cell, after which it breaks and starts like infinitely proliferating and not doing anything useful in the body otherwise, all right? And also spread into the other tissues through various means, okay? So, of course, in case of alternatives, there's just like always, pretty much, there's always like freaks, there's always stupid ideas or funny ideas sometimes, but there are also pretty well-rounded ones. Now, speaking about freaks and stupid ideas, like, about a month ago, I saw on Facebook, which is, again, the perfect place for such information to be found, one of my friends, you know, Facebook friends, posted something that cancer is a parasite, blah, blah, blah. And, well, as much as I appreciate, like, alternative outlook on things, like, no. Just no, okay? I mean, in some sense, it is a parasite because, again, it's not doing anything useful to your body. But it's not a parasite like a worm or like some sort of fungus or whatever. No, just no, okay? Still, what are we gonna be talking about? What kind of alternative are we gonna be talking about? So there are actually several alternative theories. You can possibly like name them collectively as something like tissue interaction theories of cancer. So tissue interaction theories of cancer. I'll probably provide you a link. Maybe I'll give you a screenshot of a paper which describes some of them. So most of these theories focus on a single paradoxical result of SMT, I mean, which is unexplainable from the point of view of SMT. For example, there is a detached parasite hypothesis, there is Brucher-Jamal paradigm, there is cell reversal theory, and some others. And all of them are actually non-contradictory with respect to the theory that we are going to be talking about, that we're going to be focusing on. And the theory we're going to be focusing on is called TOFT. It is Tissue Organizational Field Theory. Now, first of all, I gotta comment on the title a little bit. So this is absolutely mental that people in like the end of 20th and the beginning of 21st century use the words like tissue organizational field theory unironically in a scientific context, okay? Because it sounds so woo, you know, woo-woo magic like chakras and biofields and auras, you know, that like, why? Why would you do that? I don't know. Like, the biggest criticism I have against this theory is its stupid title, okay? By the way, if you want me to help you with the title of your majestic theory or development of your majestic theory, watch this video until the end for my self-advertisement of my alternative science coaching, okay? Anyway, speaking about TOFT, Tissue Organizational Field Theory. So it arose somewhere in the late 1990s, so at the very end of the 20th century. It was described briefly in a book, Society of Cells, which is actually written by the authors of the theory in the first place. But I'm gonna probably show you the cover of the book or something. And it was finalized, I would say, in a 2011 paper, which I'll also link to you in the description, show you on the screen, blah, 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 blah. So fundamentally, the differences between the TOFT and SMT, so that's again, tissue organizational field theory, this alternative theory, and SMT, somatic mutation theory, the currently accepted one, are such. So in SMT, in the currently accepted theory, cancer appears on a cellular level. So it's a disease of a cell, essentially, okay? Whereas in TOFT, it appears on a tissue level. So the cancer arises from an unhealthy tissue, basically, okay? And a single cell does not matter a whole lot in this sense. It could have been this cell, it could have been any other cell. If it's placed in an unhealthy tissue, it may become cancerous. That's the idea. Whereas in SMT, the idea is that you need this particular cell that already has undergone certain mutation to undergo a certain other mutation in order to become cancerous, okay? Hopefully you can see the difference. Then the second difference is that in SMT, the default state, like it's a more like a general abstract idea. In SMT, the default state of a cell is quiescence, so it's like not dividing, basically, whereas in TOFT, it's vice versa, it's proliferation. Okay, so TOFT says, basically, by default, all the cells are proliferative. They want to divide as much as possible. However, in a healthy tissue, this proliferation is suppressed by certain mechanisms. Which are they? Like, it's a subject of debate. Like, they might be physical, they might be biochemical, they might be electrical, they might be whatever else type of signals. But nevertheless, the proliferation of cells in a healthy tissue is suppressed. If it wasn't so, the cells would have been proliferating even without any mutations, even without anything of this sort as SMT states, okay? So the third difference is that in SMT, in the currently accepted model, the mutations are the reason of cancer, whereas in TOFT, tissue interaction, tissue organizational field theory of cancer, the mutations in cancer cells are actually a consequence of cancer itself, okay? So according to TOFT, if we kind of sum it all up, according to this alternative theory, cancer is actually treatable and it's actually reversible, all right? Because in SMT, in the currently accepted model, the only way to like treat or cure cancer is basically by killing the cancer cells. All right. So there are two ways. You're basically either surgically remove them or do some, I don't know, some radiation therapy or whatever, or you just take poison. You know, you inject poison, which is called the chemotherapy. It should be really called just injection of poison, okay? Because that's what it is. And then hope that the tumor cells will die before your body does, okay? That's the chemotherapy in a nutshell, okay? But we'll talk about the possible treatments a little bit later. There is only really one effective way of treatment that is known to me. I mean, other than surgery or taking poison. But again, we'll talk about this at the end of this video. So some, I underline this word, some of the observations and experiments which contradict SMT directly, the currently accepted model directly, again, they're listed in one paper. Again, the list there is actually longer. I'll link it in the description and show it to you on the screen. I'm sorry. So what are these observations? Well, first, there is a so-called bystander effect, which is a pretty interesting thing, which is observed when you irradiate some cells with some, well, radiation. I actually don't know what kind of radiation, but it doesn't really matter. So SMT would assume that these cells which have been irradiated would become cancerous. But the observation is, that contradicts the SMT, is that it's actually the neighboring cells which haven't been irradiated that are becoming cancerous, at least in some cases. Again, it is completely inexplicable. You cannot explain it through the lenses of SMT, whereas in TOFT, by irradiation, you're basically destroying the proper communication within a tissue, and that's how you get cancer, because again, it's called tissue organizational field theory, okay? You are disrupting the tissue, you are getting cancer, okay? Then we have polyclonality of tumors. So what does it mean? It's that, again, SMT says, well, you have a cancer cell which appeared through the sequence of mutations, and then it divides, and like one tumor is basically a copies of a single cell, or maybe a couple of them, okay? Or maybe three of them, all right? Whereas in reality, tumors are actually copies of many, many, many different cells, okay? This is called polyclonality. So the tumor is a clone of many cells simultaneously, okay? And you can't really explain this through SMT lenses, all right? Whereas in TOFT, again, you have a disruption of the tissue. Any cell within this tissue can become cancerous, and many do, probably, at least in some cases. Then there are tumors with no mutations, period, which again is inexplicable in SMT, in the currently accepted model. Then we have a very curious case when the implantation of foreign bodies, inert foreign bodies, for example, like something made of asbestos or cellulose, basically like paper, you know, like a small disc made of paper implanted into the tissue, it can promote cancer. And how can you explain this through SMT? Like there are no mutations. The body is inert. It's not interacting with the cells at all, with the cell's genome at the very least, all right? Yet it produces cancer, all right? And in TOFT, it's easily explainable. You're disrupting the tissue by inserting this foreign body into it. That's how you get cancer. Then an absolutely crazy observation, which I haven't been aware of, and I'm pretty sure you haven't as well, is that there were some experiments with transplantation of cancer cells into healthy tissue. And you know what happens, at least in some cases, that cancer cells implanted into a healthy tissue become healthy cells again. Do I need to make any more comments? So it's not the cells that are a problem, basically, period. It's the tissue that's the problem, all right? Hence, TOFT, tissue organizational field theory. Then, the transplantation, again, there have been experiments of this sort, of transplantation of like cancerous cell nuclei, which again contain the genetic code with all the mutations, into healthy cells. So if you take cancerous nuclei and transplant them into healthy cells, the cells don't become cancerous, which again is inexplicable in SMT, and it's understandable in TOFT, which says that mutations are just a secondary effect of cancer already taking place, all right? And vice versa, by the way, the transplantation of healthy nuclei into cancerous cells does not cure these cancerous cells, all right? So the genetic, whatever is, how would you call it? The genetic makeup of cancerous cells doesn't really make a whole lot of difference, you know? That's not the reason of cancer. So SMT, as you can see from all these observations and experiments I just mentioned, is directly, observationally, experimentally falsified. So you have to get rid of it. Like, I'm sorry, it just doesn't work. It's a wrong model. It's a wrong theory. Like, it has been falsified by both observations and experiments. So, yeah, just forget about it. Like, it's wrong. It's wrong. Like, it doesn't work. So from now on, like, it's not really clear which theory will become the next accepted theory, and actually it's not even clear when it's gonna happen, because again, given all the huge resources that the SMT possesses currently, that are, you know, politically and sociologically, you may say, economically, etc., etc., etc. But TOFT is actually not the worst candidate. As I've said, it kind of like encompasses, like integrates into itself basically all the arguments against the current theory. They can be more or less well integrated into the tissue organizational field theory, which again is this alternative model that we're discussing. And there's a case for big optimism here. Why? Because according to TOFT, cancer is curable. It is reversible. And it's kind of like, it sounds a little bit like this so-called streetlight effect, you know, when a drunk guy loses his keys somewhere in the night, and he starts looking right under the streetlight because, well, at least he can find them there, okay? He can actually find them there. So it's also like, we better use a theory which postulates that cancer is curable if we want to cure cancer, right? There is a bit of this effect here, but still, it looks like, through independent sources, again, if we're looking at these experiments and observations, that TOFT is still a better theory even without this streetlight effect, okay? Still a much better theory than SMT that we are currently using. And by we, I mean humanity at large, like the mainstream, you know? So yeah, if we figure out all the signal systems that are responsible for communicating to the cells that, you know, the tissue has been disrupted, and maybe we can reverse these signals and like fix the cells themselves, just like in these experiments with transplantation, when the cancerous cell sees, oh, okay, this is a healthy tissue, I should differentiate again and become a healthy cell again, okay? So yeah. Now let's talk about the treatment. So first of all, in order to even come to the treatment, we should figure out, I mean, at least this method of treatment that I know about, okay? Which again is probably the only way of treatment without surgery and without injecting poison, aka chemotherapy. So we need to consider cancer cells' energy mechanisms. And here I will reference Laurent Schwartz's book, and also the works of Thomas Seyfried. There's a talk on YouTube. There are many papers that he has. Like, take a look if you want to know more details. I'll give you a brief summary, okay? So the brief summary is that the key difference between cancer cells and healthy cells is in the way they get their energy. And the energy is being produced in mitochondria, as you may know, okay? These are the organelles which are producing the energy in the form of ATP molecules or whatever you prefer, like whatever you've learned so far. The difference between cancer cells and healthy cells, therefore, has to have something to do with mitochondria, that is, how their energy is produced. And it's funny that it has been known for more than 100 years. It was called the Warburg effect, okay? So, and modern experiments also show that the transplantation of cancer mitochondria into healthy cells actually makes the cells cancers. So it's this energy production mechanism which is one of the most important differences between the healthy cells and cancer cells, okay? And what is the difference in the mechanism? Well, in cancer cells, up to 80% of energy is acquired through so-called substrate level phosphorylation, or you may call it fermentation. For example, fermentation of glucose, so-called glycolysis, okay? So up to 80% is this mechanism in cancer cells. Whereas in healthy cells, this mechanism is responsible for no more than 10% of all the energy production. Okay? So they are almost diametrically opposite. The healthy cells and cancer cells in the way their energy is produced. So, to like describe the differences in this process, briefly, cancer cells ferment the glucose instead of its burning. So in healthy cells, the glucose, the simplest sugar, is burning in the oxygen, in the presence of oxygen, and it is basically turns into CO2 and water, okay? Whereas in cancer cells, it's being fermented, so there's a whole bunch of chemical reactions taking place, and a whole bunch of byproducts are appearing, but it's in the under the conditions of low oxygen. So when the cell cannot burn the glucose, it makes it ferment, okay? Something like that. It makes it undergo this substrate level phosphorylation. So paradoxically, so to sum up, in cancer cells, up to 80% energy is because of fermentation. In healthy cells, up to 90% of energy is because of burning of glucose. And so fermenting 80%, burning 90%. Cancer, healthy, okay? Paradoxically, this fermentation that takes place in cancer cells also facilitates their proliferation, because fermentation of glucose, as well as some other products, for example, cancer cells can also ferment glutamine, which is an amino acid. But paradoxically, this fermentation process, it facilitates proliferation because it produces a lot of building material. So a lot of these byproducts of fermentation process are actually directly then used by the cancerous cells to build new cells, basically, okay? Now, it's assumed, even though it actually doesn't really matter for us that much, but still it is assumed that this fermentation process is like evolutionary older, just because, again, it is assumed, once again, geologically, paleontologically, etc., that the first organisms on Earth were anaerobic, because there was just not enough oxygen in the atmosphere. So this mechanism of burning glucose must have come later, when the atmosphere was already filled with oxygen, okay? And the earliest organisms must have, again, supposedly, used fermentation instead. So it is assumed now that the cancerous cells shift into this sort of older mechanism of energy production, which is fermentation. So yeah, but what's important is that the fermentation in cancer cells actually continues even after the introduction of oxygen. So they cannot be fixed by just introducing oxygen back, you know. And yeah. So we seem to arrive at a process where there is like a slow transition from a healthy state into a cancerous state, where some sort of oxygen starvation, for example, caused by inflammation. Actually, inflammation and hypoxia, aka oxygen starvation, is kind of the same thing, if you think about it, if you look into it in detail. So this forces the oxygen starvation, aka inflammation, it forces more and more cells to, well, somehow live without oxygen. And how can they live without oxygen? They they transpose themselves, I don't know, into fermentation mode, right? They're getting more and more of their energy through fermentation process. When this critical mass of fermenting is acquired, you get cancer. That's kind of the process we're dealing with here. And it actually, like, I saw some papers where people are trying to describe this in the, on the same rails, let's put it this way, as phase transitions in physics. Like, for example, you know, you can have like something like a hypercooled water or something where it's water below freezing point, but it's still water. It's just because it doesn't have any, you know, like, condensation centers, or whatever they're called, crystallization centers more like. And then you can like hit it a little bit and it like instantly freezes throughout the whole volume, right? So some sort of nonlinear, like, chaotic dynamics may be happening here as well. Like, it's a transition from a quantity into quality, you know, this slow creeping in of anaerobic modes of, breathing, the fermentation of glucose instead of its burning. And then, like, it snaps and turns into cancer at some point, alright? So anyway, the prerequisite for all of this is, inflammation or oxygen starvation, or any sort of other tissue disruption which can lead to one of these. Again, easily explained by TOFT, has nothing to do with SMT, just doesn't even have the vocabulary to describe what we're dealing with here in the first place. So it's, again, a failed theory. Forget about it, okay? The currently accepted model. Yeah, and from all of this follows what? That we can treat cancer by preventing the cancer cell from fermenting glucose, from fermenting glutamine, all right? So because if you don't give cancer cells any glucose and any glutamine, they would lack energy because they can't burn glucose anymore, okay? They can only ferment, and only glucose actually, and glutamine, all right? Well, maybe some other compounds as well. I'm not a chemist, okay? But primarily glucose and glutamine. Therefore, if you cut in your diet glucose and glutamine, yes, you are effectively starving the cancer cells, okay? So you don't give them material for cell division as well as the energy production. And it's actually working both ways, you know, like most of the glucose you consume would be taken by tumors anyway. So you're not doing your body too much harm. I mean, if you have a tumor already, because all of the glucose it will eat up anyway. Your healthy cells wouldn't get it. Okay. So yeah, it's like scoops it up like crazy actually from your blood. So therefore, how do you treat cancer according to this? By fasting and ketogenic diet, okay? So fasting, lowering your blood glucose, like it starves the cancer cells, and ketogenic diet, what it does, it's composed mostly from compounds that cannot be fermented, okay? So cancer cells cannot use this energy, whereas the healthy tissue can, okay? So literally the tumor will eventually die out, you know? That's how it works. So again, unfortunately, we still don't have a precise understanding of all these signal mechanisms through which, you know, the tissue is organizes itself, right? So we can't really revert the cancerous cells to healthy cells, even though, again, TOFT says it's principally possible. But we just don't know how to do that yet, so at least you can starve them, okay? Without taking poison, aka chemotherapy, okay? So yeah, healthy cells can utilize all these ketonic bodies, etc., but cancer cells cannot. So in case you're interested, I've given you already enough keywords. You can find the information. Just like the main takeaway that I would like you to have from this video is that SMT, somatic mutation of cancer, is absolutely bankrupt. Just forget about it, okay? TOFT, tissue interaction, tissue organization field theory, again, stupid title, but I can't do a whole lot about it. Like it's already accepted as a term, is much better, okay? And from TOFT, it follows that, well, a lot of things follow, okay? Watch the video again if you forgot already. While I was preparing for this video, I found out that Schwartz actually had another book of his published relatively recently, like the previous one that I mentioned. It's already quite old. It's like 2004 or something. Could be even earlier. But he had another book in terms of treatment specifically. And there, again, take it all with a grain of salt. Like, I don't know, this is not a medical advice, blah, 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 blah. But he recommends to reduce the acidity, actually, which again, in his eyes, acidity helps, again, supposedly, helps cancer cells to suppress the neighboring healthy cells and thus promote the tumor growth, okay? So the acidity itself is the byproduct of fermentation itself by cancer cells, okay? So he proposes to lower the acidity and therefore kind of like lowering the capability of tumors to counteract the neighboring healthy tissue, okay? And so he recommends drugs like amiloride, omeprazole, acetazolamide, and some others, okay, for reduction of acidity. But then again, do your own research if you wish to know more about it, okay? Then he also proposes to restart the mitochondria themselves so they would start burning the glucose again. I have no idea on what principles. Again, I've not read this newer book of his, so I don't know which principles he bases his ideas on, but he recommends to take lipoic acid and hydroxycitric acid. for this end, to this end, okay? Or again, you can go through surgery, or you can inject poison and hope that the tumor dies before you do, okay? That's your choice, ultimately. And by the way, finishing this video, just today, I'm recording this on March 19th. So, this video is going to be on Patreon like either today or tomorrow, depending on when I'm going to be able to render it and upload it. And it's going to be up on YouTube, like maybe 2 weeks later. Already in April, probably, but we'll see. Anyway, yesterday, so March 18th, the authors of this TOFT, Tissue Organizational Field Theory, have published another paper, kind of again, summing up the recent years of the development of the theory and of the observational data supporting it. And again, the conclusion is the same, that SMT is absolutely bankrupt. Just forget about it. Use TOFT if you need a model of how cancer works. And again, if you want to know my opinion, use Schwartz and Seyfried's works in case you want to have an idea how to treat cancer at the modern level, where we don't really understand how to revert the cancer proper. At least we understand how we can cut its energy and building material base, and that is through fasting and ketogenic diet. Thank you for watching. The eons are closing. If you wish to support me, please consider joining my Patreon. That is patreon.com/philosopher. See the link in the description. Or if you have a scientific theory of your own and you'd like my help in developing it, please join my alternative science coaching program, also available through Patreon.